Now, in the long run test, same connection will be used, but what we will do compared to the short run test is that we will run the meter for a long duration of time. As for example, 10 minutes, 20 minutes, 30 minutes. We will measure how much energy this energy meter is registering. Since our time duration we are fixing either 10 minutes, 20 minutes, 30 minutes, and we are keeping the load constant for that period. So the wattmeter reading remaining constant for that duration, if we multiply it by the corresponding time, the total will give us the energy of the standard. Here, after 10 minutes, we will find out what is the final reading of the energy meter, and from that we will find out how much energy this energy meter has registered. So this reading will be test reading, this will be standard reading, and accordingly we will do that one. Since we have shown this is a 230 volt energy meter, so like the previous case, we have injected 230 volt here itself. Two 30 volt is there, we are injecting. Before switching on the loads, we will measure what is the present reading of the energy meter which is registered. This is the 1000 scale, it is written 1000 here, like 1, 10, 100, 1000 in our class 2, class 3 levels we have seen. So this is the 1000 scale. So it has crossed, if you see this dial, it has crossed 1. So in the 1000 position, we will write 1. In the 100 position, it has crossed 1. So we will consider that, okay, it is considering 1, 1, and then 10 scale is close to 0, but crossed 9, but not reached to corresponding 0. So our reading will be 1. This is not 1. Since if it would cross 0 and would come 1, then we could understand it is 1, 1. But you see, it is about to reach 0. That means it is completing one full revolution, then it is coming here. Its one complete revolution will move this dial by one scale from 1 to 2, suppose from 0 to 1 or 1 to 2 or 2 to 3, like that. Since it has not completed the full, after starting from 1, it has not returned to 0. That means it has not come to 1. You can ask me, sir, why you are not considering crossing the, it has crossed 1. If it would cross 1 and after that if you, it would complete the revolution, then it would reach to where? Almost close to 0. That means after completing 9 means it's, this dial should come close to 2, because its reading would be 119 something. But since it is close to 0, so it has not crossed 1. So it will be 1, 0. Then this is 9, 109. Then this will be, this has crossed, you see 7, 8, 9. So 1, 0, 9, 9. Then this is, this two red is decimal. It is 1 by 10. This is 1 by 100. So 1, 0, 9, 9. Point. It has crossed 2. So 0.2. And this has crossed, you see 1, 2. Then after that it is about to reach to 3. So it has not reached 3, rather we should say it has reached 1 2. Yes, almost 1 2 it has come crossed 2. Then after that maybe it has crossed 4 small deviation. That means reading would be, its reading would be, energy meter starting reading would be 1, then 0, then 9, then what we have seen, 109, then it has crossed 9, 1099, then decimal, after decimal it has crossed 2, 2, then after this it has crossed 2, then it has completed 4 decimal, that means 24. So my reading is 1099.224 initial reading. Now I will take a stopwatch. The moment I will switch on the load, that instant itself we will start the stopwatch. So it should be synchronized. Then after that, in our case, we will wait for 10 minutes for this purpose. These are the switch with the help of which we can switch on the stopwatch. You can show the stopwatch to them and they will listen the noise. Instantaneously you will switch on the stopwatch. Okay. So the stopwatch has started counting the time. In that way we will wait for 10 minutes. By that time what we will do, load voltage, load current, other values we will. Now in this case it is not required. Okay, standard reading is required, voltage and currents are not required according to the observation table. So let us wait for the wattmeter to settle down. This wattmeter got slightly defect, has become defective, that's why it is getting more time to settle down. Actual wattmeter, if it would be fully accurate, it will not take that much time to settle down. Almost 92 watt like the previous case. So we will write test wattmeter reading 92, multiplying factor is same 4 watt. So final reading we will have to note down and 10 minutes we will wait for it. So whatever time will be recorded, that time we will have to take. Then this wattmeter reading will be multiplied by time. After converting time in hour, we will multiply, we will get the watt hour reading of the standard. Then we will compare this difference between the standard watt hour reading and the test watt hour reading, and we will calculate this one. It's going on. Let us wait.